Hello, my name is Tarek, and our today's lecture is on a very important topic, which is time complexity. In our lectures, we are going through with data structures, different data structure. We saw list data structure, linked list data structure, stack data structure, and these data structure are based on algorithms. An algorithm is a way, it's a procedure to write programs. So algorithms play a very important role in implementation of the different data structures, and the complexity of those algorithms is very important. We need to understand that an algorithm can be a performance friendly algorithm, or it can be a costly algorithm. So it's very important whenever we are designing a data structure or we are writing any program, from programmer's point of view, or from you can say an efficient programmer's point of view, it's very important to know how the how his algorithm will work based on the input size. So let's start this lecture, and we will focus on the time complexity, that how can we measure that our algorithm is an effective algorithm, or it's 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 a kind of a poor algorithm. It's not giving us the required benefit. So today our lecture will be focusing on the time complexity. How can we measure the time complexity of an algorithm, and how important it is uh, in the subject of computer sciences. So what is an algorithm? An algorithm is a finite set of precise instructions for performing a computation or solving a problem. So algorithm is nothing but it's a procedure that we write, a method that we write to solve any problem. And the synonyms of the algorithm are, as you can see, a program. You can call it a program, a recipe, a procedure, or a method. So we have written many methods in our previous lectures. Like whenever we implement any data structure, we write different methods. Like in linked list, we wrote the add method, the remove method, the insert at method. These methods, what are these? These are algorithms. And what they are doing? They are solving a problem, or giving us the required results. So it's very important to know that our algorithms are effective, they are fast enough to give us the result or not. Okay, so let's say let's say there are four programmers who are working on the same problem, and which now the point here is which programmer's program is the most effective. Like writing a program is not a very big problem. A computer science student or even a fresh graduate can write a program on a given problem. But is his or her program effective enough and fast enough that it solves the problem in the required time? This is a big a question, and we need to answer this. And in our real life, every company, every big company analyzes a programmer's program to understand his effectiveness, to understand the quality of the programmer. So now there are four different programmers working on the same problem, and the point here is which programmer has written the best program. So the big question is, how effective is an algorithm or a piece of code, right? Okay, so now when analyzing an algorithm, we take two elements into consideration: time and space. To analyze an algorithm means developing a formula developing a formula for predicting an algorithm is how fast an algorithm is, based on the this is important, based on the input size, or based on the size of the input. we analyze our algorithm with respect to the input size, and this input size then tell us that what is the time complexity of the algorithm. We will see, don't be confused if you are not getting uh, anything here. We will see in depth how our programs run and how we can evaluate or how we can measure its effectiveness. So the first point is the time complexity or the time, and we measure time based on the size of the input. And the second one is the space, or you can say the space complexity. Developing a formula for predicting how much memory an algorithm requires based on the size of the input. Now, one we have first is the how fast an algorithm is, right? How fast, and the second is how much memory, how much space the algorithm requires to run. With the advancement of the hardware stuff, that we are getting the very in hardware industry, the prices are cheaper, the prices are getting cheaper, and we are getting more space in less amount, or you can say in less investment. We so the space is not much a issue for us. We can like in past days, buying a computer was a very was not a very easy task. That um, program computers were very costly, but now the prices of hardware has gone down very much, and we can buy a, 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 a space in a very less amount. So the uh, hardware is not a big problem for us, but the time is, yes, time is something which we need to take care very seriously, because in application like airline applications, or you can say the reservation systems of any airline or railways, or in the events like Christmas and Eid, where time becomes a complex, or you can say time becomes a very important factor for businesses. So the businesses cannot compromise on time. They can have space, they can buy the most perfect systems. They do not care about the space, but the time is something which they cannot compromise on, right? So this space complexity is not that much important nowadays, because it's reachable, is purchasable, or you can say it's within the affording limits. But for time, no one can compromise, right? So usually time is our biggest concern, and most algorithms requires a fixed amount of space. As far as the algorithms are concerned, they require some fixed space, which cannot be a big problem for the programmers. So now we have two things, and now moving forward, performance and complexity. How much time memory, disk is actually used when a program is run. This depends on the machine, compiler, and as well as the code. And the complexity, how do resources, how do the resource requirements of a program or algorithm scale? What happens as the size of the problem being solved gets larger? Again, the complexity is what? The size of the problem, right? The size of the problem being solved gets larger. So the complexity is directly proportional to the size of the problem. If the size of the problem increases, the complexity increases. The size of the problem decreases, the complexity decreases. But here we will tackle that if even the size of the problem is increasing, we will write such programs that they will perform good, they will perform as per the requirements. This is what we need to achieve.